Previously on Summiting the Solar System. Stories of what it felt like to be among the very first to see the new pictures in science returned by New Horizons during its historic encounter with the Pluto system in July 2015. How an ambitious ground campaign in Senegal helped target New Horizons for the upcoming January 1st, 2019 flyby of Kuiper Belt object MU-69, informally nicknamed Ultima Thule. And how the mission's own Apollo 13 moment saw heroic round-the-clock efforts by the mission ops team save the day after a major computer malfunction just 10 days before closest approach. Now, the story continues with what it took to get New Horizons funded and off the launch pad. Adventures in South Africa, Argentina, and high above the Pacific aboard NASA's Sophia Flying Observatory, chasing MU-69's fleeting shadow and capturing essential information about its possible shape to help target the flyby. How MU-69 and its companions in the Kuiper Belt, our solar system's third zone, hold clues to what happened 4.5 billion years ago. And the challenges faced in late 2018 as the New Horizons team makes final course corrections and tries to detect any mission-ending hazards around Ultima Thule. But first, the long road to launch and the personal stories of what powers the mission. The epic story of New Horizons continues in Summiting the Solar System Part 2, Approaching Ultima. December 2014. After 8 years in flight, many spent in what was called hibernation, it was time for New Horizons to wake up for what was to be the year of Pluto and a successful flyby on July 14, 2015.
We had a nominal wake-up of the New Horizons spacecraft on our way to Pluto.
Well, hello there. Greetings, New Horizons. This is Russell Watson.
NASA had arranged for a special wake-up from English tenor Russell Watson, who'd sung similar greetings to astronauts in orbit.
It's been a long road, and getting from there to here. It's been a long...
It had indeed been a long road, and a long time. The journey began on a farm in Kansas, where a young man, Clyde Tombaugh, was so poor he made his telescopes from leftover farm equipment. Lacking funds to go to college, he was still a skilled observer and made surprisingly good images of Mars and Jupiter. He sent them to the Lowell Observatory in Flagstaff, Arizona, which had been founded by a wealthy Bostonian, Percival Lowell, initially to look for life on Mars. Next, he moved on to search for a planet X, which Lowell believed was lurking out beyond Neptune. In 1929, hard up for funds, the observatory was looking for an inexpensive worker to support what seemed a fruitless search, and to handle tasks like shoveling snow and stoking furnaces. Tombaugh turned out to be the perfect hire. In long, cold nights at the telescope and long, tedious days at a machine called a blink comparator, young Clyde labored away. Finally, on plates taken on January 23rd and January 29th, he saw a tiny dot that moved, a new planet. The announcement made worldwide news, and there was widespread interest in proposing a name. An 11-year-old English schoolgirl, Venetia Burney, suggested Pluto, the Roman god of the underworld, which was accepted. But Pluto remained just a dot for decades. Then, in 1978, astronomers Bob Harrington and Jim Christie analyzed plates taken by the Naval Observatory, also in Flagstaff. At first, they suspected a glitch, since the pictures seemed distorted. But after checking images taken on separate dates, Christie deduced that Pluto was being orbited by a large moon. He suggested the name Charon, after the ferryman in the underworld, in part to honor his wife, Charlene. And Charon, or Charon, was accepted. Charon was almost half Pluto's size, and their orbital motions allowed astronomers for the first time to calculate their relative masses. Still more importantly, and with great luck, between 1985 and 1990, Pluto and Charon would eclipse each other as seen from Earth. That allowed astronomers like Mark Bowie, then working at Lowell, to use the so-called mutual events to generate crude maps showing a pattern of bright and dark patches on the planet. In 1988, astronomers, including a young grad student, Leslie Young, who'd later become a key member of New Horizons, took off in NASA's Kuiper Airborne Observatory in an experiment to see if Pluto had an atmosphere. As this cartoon shows, if a celestial object did have an atmosphere, a distant star's light would gradually fade out and then gradually reappear as the object passed in front. This in-flight video records the actual moment of discovery.
I think it's raining. It's raining. It's raining on the track. Yeah, it's raining here too. No. I think that thing has an atmosphere, guys. Yeah, it has an atmosphere.
With clear proof of an atmosphere, Clyde Tombaugh's dim and distant dot had become even more interesting. 1 year later, after a scientific meeting in Baltimore and over an Italian dinner, a group of young astronomers started a series of meetings to push for a mission to Pluto. They called themselves the Pluto Underground. Many members of what would become the New Horizons team enlisted: Alan Stern, Fran Bagenal, Bill McKinnon, Dale Cruikshank, and more. With the successful Voyager flyby of Neptune and its intriguing moon Triton, NASA's head of solar system exploration, Jeff Briggs, okayed the first of many study groups. All through the 90s, designs for possible Pluto missions were proposed, costed out, revised, and changed. But more importantly, the 90s also saw the discovery of the Kuiper Belt, named for astronomer Gerard Kuiper. He'd theorized there might be a ring of icy objects out beyond Neptune. In 1992, David Jewett and Jane Liu used a telescope in Hawaii to detect the very first Kuiper Belt object. Like Tombaugh, they did it by looking for changes over time, spying QB1. It was just a few hundred kilometers across, about the size of an asteroid. But progress on Pluto itself needed telescopes in orbit. In the mid-90s, Bowie and Alan Stern used the Hubble Space Telescope to make the first direct images of Pluto's surface.
It's exciting to Mark and I and to our whole scientific team to be able to see this object that no humans really could glimpse as a real planet, as a real object in the solar system previously.
In 2000, competing priorities within NASA and budget issues led to another of the 7 cancellations of a mission to Pluto. Advocacy groups like the Planetary Society pushed to reverse the decision. But it was a 17-year-old student who helped win the day.
You know, I just wanted to see us go there and see what we could learn about it.
He launched a website petition from his bedroom. Interest from press and public was massive. The website crashed. Ted went to D.C. and met with NASA, and the mission was back on. But what finally got the New Horizons mission approved was the National Academy's Decadal Survey, which ranked the mission to Pluto and the Kuiper Belt top of all priorities. November 2001, with the Johns Hopkins Applied Physics Lab in Maryland as home base and Alan Stern as principal investigator, New Horizons was finally a reality. Plans on paper became metal in clean rooms. The next 5 years were a whirlwind of engineering innovation to keep both weight and costs down. Meanwhile, discoveries about the Kuiper Belt continued. In 2002, far beyond Pluto, astronomers sighted Quaoa with a tiny moon. Next year, Sedna with a strange and highly eccentric orbit taking it far from the Sun. Meanwhile, at APL, the spacecraft was being assembled in clean rooms, and the mission ops team of engineers and flight controllers practiced with rigorous mission simulations. They responded heroically to the anomaly of July 4th, 2015, but the roots of that success were planted a full decade earlier.
It's an exciting mission. To be a part of this team draws people to it. So it's good that we can do that, so they will have both the time, the focus to stay with the mission over this long period of time.
Along with testing the spacecraft, New Horizons needed to train and test its human operators.
Normally we're focused on subsystems and instruments in the spacecraft surviving that duration, but for people we have to have a longevity plan.
For a mission that would be more than 9 years in flight, it was important to have young people on board early so they'd still be around at closest approach.
The ability to practice things are all part of the planning now to assure mission success then.
Here I am in 2000, that's when we started the mission, and we don't get to Pluto till 2015, and to think of how old I'll be when we actually get there.
How old are you going to be?
In 2015?
Yeah.
I don't know, somewhere in my 40s.
Oh, and you're a youngster.
Yes.
We also have to be sure that we have in-depth documentation so that we can understand what we did in 2004 in 2015.
Alice and Glenn were sufficiently concerned about ensuring that knowledge of spacecraft systems and procedures were captured that key mission personnel, such as Gabe Rogers, Flight Controller Becca Seppen, and Stephen Williams, made DVDs for future reference. Out in the Kuiper Belt, more and more discoveries. In 2005, KBO Eris, once thought to be larger than Pluto with its moon, Dysnomia. And in the same year, Makemake. Also in 2005, Hal Weaver and Alan Stern used the Hubble to discover 2 small dim moons around Pluto, where only Charon had been seen before. In 2005 and 2006, final assembly and testing sped up at APL and NASA's Goddard Space Flight Center. To get to Pluto before its atmosphere froze out, they needed to make a 2006 launch and a 2007 gravity assist from the giant planet Jupiter.
If you want to fly to Pluto on the quickest route, you need Jupiter in position. And that means we have to launch in January of 2006.
3, 2, 1. We have ignition and liftoff.
Glenn and Alan were there, of course, along with science celebrities like Bill Nye, Patsy Tombaugh, Clyde's widow, and Jim and Charlene Christie. 18 years after helping discover Pluto's atmosphere, so was Leslie Young. We now know they made it to Pluto and succeeded magnificently, but one key technical innovation is little known. For about 2/3 of its cruise from Earth to Pluto, New Horizons was in what's called hibernation, the first NASA mission to use this technique to save wear and tear on its systems. Scientists and engineers could also use the time to plan the Pluto encounter and save money by using a much smaller team than had missions such as Voyager and Viking. Alice's mission ops team had a simple way to indicate what state the spacecraft was in. When asleep and sending just a simple weekly beacon back to Earth to indicate all systems were operating fine, they had a bear mascot resting in mission control. When the spacecraft woke up for new commands or to take science observations, it was time to put on a party hat. Along the way, there were cakes to mark mission milestones, breakfast gatherings to boost morale and build a team to call on at moments like the July 4th anomaly. They built a rugged spacecraft and a committed and resilient team to fly it. Looking back, they didn't regret the long hours, late nights, and holidays worked.
This was so worth the last 17 years of my life. Even when I was working the hardest, I was working with great people. And just getting to know the other scientists and engineers that I got to know was worth it. Learning new techniques, learning new ways of approaching problems.
We have team members who have been with the mission from the very beginning. Okay, I've been on this for 18 years, I think now. So when you have continuity in people, and you have that depth of knowledge of the systems, the ground systems, the flight systems, then you have resiliency, right? You can take a punch and you can punch back, and you can find a way to fix a problem under the most stressful situations.
I sure am glad that we put the effort into building New Horizons, specifically to fly out to Pluto, in taking all the stuff that we learned from ground-based observations that I was a part of, to design the perfect experiment for the first reconnaissance of Pluto. And the results we got is a testament to that particular pathway for discovery.
And I think that discovery and the challenge of planning for discovery is what drives scientists to do the long days, the long nights, and taking the risks for the big return.
One of the best parts of New Horizons was that everybody on the project, from the time we got started, knew that they were on something really special. That in our parents' generation of space exploration, it was always special to be on a first mission to a new planet. First to Mars, first to Venus, first to Mercury and Jupiter, so forth. But really, that was wrapped up before our time, except for Pluto.
People were starting to think that, we've kind of seen it all. We've sent a spacecraft up to visit these places. Now let's just go in and dig into these little tiny problems and drill deeper and understand in more depth these amazing objects that we share our solar system with. But I was convinced from the very start that we were seeing a new chapter opening up for us. Most people didn't really realize just how deep that story's going.
And to be able to be on the Pluto New Horizons team was very special. We knew that when we were hiring people, and people talked about it across the entire 15 years we were doing the project. They were on something really landmark and historic, the capstone to the reconnaissance of planets, and the last train to Clarksville, if you will. The only mission that was really going to big real estate that was left in the solar system. And to a person, from scientists to engineers to mission operations people to technicians to the business people that do schedules and budgets, everybody knew they were part of something larger than life and really historic. And they were making a real contribution, not just to knowledge, but to the history of exploration.
Like athletes getting ready for a marathon or a Super Bowl, or soldiers in the heat of battle not wanting to let their comrades down, the long road and many years had been a struggle worth the effort.
You don't want to let your colleagues down. You sort of feel like there's a burden of responsibility. We're not going back to Pluto. We're not going back to MU69 anytime soon. And so you feel like there's a burden of responsibility, not just for yourself because you want to do the best you can, and not just for your colleagues because you want them to succeed too, but it sounds cheesy, but for the whole of humanity, because this is our chance to look at MU69. That was our chance to look at Pluto, and you have a duty of care to make sure you've done the best you can. So it feels like a big responsibility, and it is a big responsibility, but we are trained well, and we have a lot of backup, we have a lot of support within the team. So everyone wants everyone else to succeed, and so you have a pride in your work and you have a confidence in your work, but it's with a heart in your mouth that you wait for those images.
To capture new images of MU69 requires the sophisticated instruments of New Horizons and all the rocket science skills of the men and women who fly her. But planning details of the flyby required mobile telescopes and schlepping heavy cases in Argentina and South Africa, and some very down-to-earth hard work. That's next. The occultation campaign of August 2018 in Senegal helped confirm the orbital position of Ultima Thule. With so little known about this small Kuiper Belt object, 4 billion miles from Earth, every scrap of data was important to plan the January 1st, 2019 flyby. But one question that will only be resolved by flying by is whether Ultima is a close binary, a contact binary, a lumpy and potato-shaped single object, or something else entirely. That mystery resulted from an amazing series of occultation experiments in the summer of 2017.
We're really hoping to get this one because this is our last chance.
The New Horizons team was in Comodoro Rivadavia in Patagonia, Argentina. They'd soon discover, for good reason, that Comodoro is known as the capital of winds.
If the wind affects some of the telescopes, we could lose data, and it's been pretty windy.
So these are portable windshields that we're going to put up in sites where we have very high wind.
Yeah, hopefully this will keep the telescopes from shaking.
Well, right now we're trying to set up the windbreaker, wind stopper,
They'd spent 3 long, cold nights in practice observations with a dress rehearsal on July 16th.
The dress rehearsals have gone really well. We tested everything we needed to test, and so far, so good.
Now, it all depended on wind and weather for occultation night, July 17th.
Today is the end of a very long journey. I got roped into this back in February, and 3 opportunities to watch 2014 MU-69, this tiny, small little rock in the outer solar system, pass in front of 3 different stars on 3 different nights. And we've had 2 of those already, June 3rd and July 10, and we're now tonight going to witness the 3rd.
The first occultation opportunity had been June 3rd in both Argentina and South Africa.
We have about a dozen teams here and another dozen teams in Argentina. Each team comprises 2 people that work in pairs.
I think this is the road right here.
That's that back road. Now the challenge is finding somewhere to put that telescope. You know, where on this line do we have to find an empty space that's kind of dark, remote, where we can see this occultation.
Meanwhile, for the June 3rd opportunity, another team was preparing in Mendoza, Argentina.
Pick the best site you think, with what you know, could do that chord. The one thing you might be interested to note that the mean spacing between sites is about 8.2 kilometers. So we've got 23 mobile sites, and we're adding 3 fixed to that, so we've got a total span of 26. Teamwork is an essential component of an occultation deployment. Everybody's got a role to play. Besides the basic competency to know how to run the equipment, they are also resourced to go and do problem solving. When we get here, we don't know exactly where we're going.
There are some poisonous, not only snakes, but also spiders. There's only one hospital in the area that can treat bites.
Tonight we are going to go practice at one of our sites where we're probably going to observe for the night of the event. We're going to send out 4 teams each to 3 different campsites.
Larry Wasserman from the Lowell Observatory is an expert in calculating where to travel for difficult occultations.
Set longitude.
You've got to get yourself in a telescope in the right place, somewhere in the world, at the right time.
Light is the instrument of astronomy, and sometimes that's very limited, such as in this case where we're sending 55 people across the world to catch a 2-second shadow.
We're used to space science being done in clean rooms and pristine labs. Not this experiment.
So when we were scouting the site earlier today, we were driving on a dirt road for about 4 hours. And so everything in the back of the truck got very dusty. And so we're dusting off the cases right now so that when we open them up, we don't get too much dust on the telescope.
Observers included New Horizons researchers, but also volunteer amateur astronomers. So practice with the portable telescopes was critical.
So what's happening here tonight is we are practicing using the equipment and setting up the telescopes.
So now I'm going to attach the azimuth motor control, which connects here.
It's a little bit cloudy, and that's making things difficult. It's a bad thing and a good thing, because this is not the kind of weather that we're hoping to have on occultation night.
In fact, clouds were forecast for Clan William in Western Cape Province. So the team gathered to try to reach a consensus about how to solve that all-important problem.
10 fog. You guys are going.
We're going. Well, I mean, things keep changing, but that's just the nature of chasing an occultation.
You know, the biggest risk we have right now is weather.
Hoping for clear skies, but we know that the forecast is for clouds to roll in here. But at the event time, right when we need it to be clear, I think it's going to be hit or miss. We might get a hole in the clouds, or you might not.
Do we know what the weather situation is in Argentina? But maybe if their weather's awesome, then splitting would be the best idea.
With sometimes spotty communications across continents and time zones, they tried to figure out the best strategy for success.
We should just designate 6 teams to stay, 6 teams to go, and give us new lines, and keep it simple.
Now we're splitting up. We're trying to chase the clear skies, get away from these clouds. So we've sent our team out to Kourou, and hope to get in there about 1 o'clock this morning. It's a little too risky to stick around here, the cloud cover.
That is why we sent 6 teams way east of here, where skies are guaranteed to be clear.
We'll head out there and scout and try to catch this thing. That's the point of being here.
54 people go into 2 different continents to watch an event that takes 2 seconds to happen. Overwhelming.
The Eastern teams drove 600 kilometers non-stop. Then, with little to no sleep, they started searching for observing sites, meeting friendly hunters with bloody hands on game ranches.
If you can, I will give you my phone number. If you can give me just a phone call when you get to the gate.
Across the globe in Mendoza, Mark Bowie tried to position his telescopes, assuming South Africa was going to be clouded out.
If you say that South Africa is taken off the table and it's only Argentinian data, the odds of a bad result was pretty high. The weather is worst at Cape Town and it kind of grades off. So if they're on Wind 7, they have a fighting chance on the north end. I like that grid. It looks pretty nice. It's symmetric. We could take that and slide it a little bit.
In South Africa, neither the Eastern team nor the group left back in Clan William saw an occultation. And even with clear skies in Argentina, there was no sighting of MU-69 passing in front of a distant star on June 3rd. The second opportunity of 2017 was July 10th. But then, the shadow path crossed mainly over ocean, not land. The only way to chase it was to use the US-German Sophia Flying Observatory, deploying out of Christchurch, New Zealand. Chasing a 2-second shadow over the Pacific took careful planning and coordination between the New Horizons observers, the NASA pilots, and Sophia's flight director.
Welcome to the mission brief for Flight 417. This is the MU-69 occultation flight.
So for the last 2 days, we met up with the mission planners and the pilots.
Weather, as you saw this morning, we had plenty of fog out here. That has lifted and is forecast to come back tonight.
The SWIRI scientists were still updating the predicted latitude and longitude and time of where we needed to place the plane.
Later, the mist had lifted, and Sophia, a massive Boeing 747 with a telescope mounted in a strengthened fuselage, was cleared for takeoff.
What we're doing here with Sophia is putting a very large telescope into the occultation path so that we can probe very close to the target.
The reality is there's so many details. What are the winds doing? And where are the flight paths for the airplane? What altitude you're going to go? The last second they ended up picking up a headwind that was slowing the airplane down, and the pilots had to adjust and adapt constantly.
And I show a spot on. 2 minutes to go. 30 seconds to go, we're looking good.
Ready. Mark.
Yeah. Okay. Excellent job, everybody.
Success tonight is putting Sophia in the right place at the right time to have that big glass, the 2-meter telescope, observing the occultation star as it passes close to MU-69 and giving us a trace all the way across the space near it for debris. If we can get that, Sophia will have done its job and done something no other observatory could do for this occultation. And it'll be a real credit, I think, to the entire Sophia program.
From an operational standpoint, getting to an occultation point on a 10-hour mission within a second of when the scientists wanted us to be there and exactly on the latitude and longitude was a challenge for us tonight, but we pulled it off, and it was a really wonderful piece of crew coordination between the mission director, the navigator, and us flying the airplane. But from what I understand, we nailed it on the head and within 1 second and exactly where we needed to be. So I think the scientists are quite happy.
Really, the point of these occultations is the hazard search. It's to make sure we can go close to the object. And the fact that we have not seen any obvious rings so far in any of these occultations says that we can go close to the object and have a really close, exciting flyby.
Despite the incredible achievement of being in exactly the right place at the right time, it wasn't initially clear whether they'd caught the shadow.
Our quick look data reduction software did not reveal the occultation dip in the light curve immediately to our eye, but it is very difficult, and we anticipated it would be very hard to see it with our eyes immediately, because all you have to do is blink and you've missed it. But all the data was taken, and now the data is being analyzed.
The third and final opportunity of 2017 was back in Argentina on July 17th. Would it be 3 strikes and you're out? Or third time's the charm? To have enough time to plan the 2019 flyby, they needed to do everything possible to ensure success. All 24 telescopes were redeployed to Comodoro. Knowing they were in the capital of winds, the team worked with local scientists and universities to come up with designs for windbreaks that could be placed around the telescopes.
Tonight is the big event. There should be a star that blinks out, but who knows if it's actually going to happen.
So this third occultation feels really important because if we don't catch the object this time, we'll have a lot less information going into the encounter.
Right now we're building windbreaks. So we're rolling out tarp, getting them measured to build these things about 4 meters by 4 meters.
The current predictions for event night are 20-mile-an-hour winds, and the telescope tends to sort of shake around if it's that windy. So we want a windbreak in front of it.
Oh, I think we cleared out the town of all this material. We got about a third of a kilometer of the tarp, third of a kilometer of the steel, and about a kilometer and a half of rope to try and pull this off.
It's going all right, man. We're welding some stakes together. I try and maybe put a little some crossbars on these guys right here, so that you can only drive at a certain distance into the ground. And I've had a lot of silly careers before this. Man, I was a blacksmith and a carpenter and a plumber, electrician, paramedic. You know, I mean, I kind of took a cantankerous route through life, my friend. I don't know how I ended up here. This is awesome, right?
In case the tarp and middle windbreaks weren't enough, the local authorities contributed large trucks to block the gusts.
The Argentine people have been extraordinary with the team, starting from the mayor of the city that welcomed us with open arms, and we use their track to shelter us against the wind. So I think they went well beyond the call of duty, and we're really, really grateful for all the support.
I want to just say thanks to everyone for the past few days of work, and to some of you for the past few months of work. Let's go get the data tonight.
Con Sang and Ann Verbisher had been part of the team in South Africa. Now they were ready to fight the winds and chase MU-69's shadow.
Well, we're about to start in 10 minutes, all right.
All right, hammer time. Okay, within the next minute. And I will tell you if I see the star disappear. Oh, I saw it!
No way.
I saw it. I'm pretty sure I saw it.
Holy cow.
I actually saw it.
Holy cow.
No, I really did see it.
Several teams thought they'd seen the star wink out. But Amanda Zangari worked all night to verify the telltale signature of an occultation. Finally, at 5:30 a.m., she thought she had enough data to show Mark and the team. All the guide stars aligned. But would the target star blink out?
Okay, we saw it.
Yeah, we saw it too.
We
Did you see it? Did you see it? You saw it, right? That's it. We got it.
We as a team succeeded in getting not one, not two, but 5 different occultations. So we saw the star go out and come back as MU69 passed in front of the occultation star at 5 different locations.
The timing of exactly when the star blinked out and reappeared at the 5 different locations allowed the researchers to infer a shape for MU69. It looked like a possible binary object, 2 chunks of ice and rock orbiting close by or stuck together. Although that might complicate trajectory planning later in 2018, this was an incredibly important result.
It was like finding a needle in a haystack, and to be able to capture those 2 seconds just at the right time, where the sky was clear, where the winds were not more than 7 kilometers per hour, where all those conditions had to be given, it was an incredible orchestration, and I think everything conspired for success. So this was critical data, not only to maximize the science return, but also to mitigate the risk to the spacecraft. It was like the night before Christmas.
I don't care what the weather is today. That's a great feeling. Here it is Tuesday. It's rainy, windy, cloudy, really nasty stuff for astronomy. And it doesn't matter. It's great. It can do whatever it wants as long as I can get out on my airplane back to Buenos Aires tonight. It could snow 10 feet tomorrow for all I care. But we got what we came for.
Carrying forward results from chasing Ultima's shadow in both 2017 and 2018, the New Horizons team were more and more ready for the 2019 flyby, 4 billion miles from Earth, out in the solar system's third zone. For many people, the Kuiper Belt is unfamiliar, so perhaps it makes sense to begin to explore it by comparing it to an astronomical feature somewhat closer to home.
Most people know about the asteroid belt. So this is a group of rocks that are hanging out between the orbits of Mars and Jupiter. And it's this sort of belt that goes all the way around the sun, just a whole bunch of rocks that are orbiting. Now there's a new thing called the Kuiper Belt, that beyond the orbit of Neptune, out 30 times the distance between the Earth and the Sun, we have a huge cloud of not rocks now, but ice that is orbiting the Sun in the same way.
We call the Kuiper Belt the third zone of the solar system. It's the newest region of the solar system we didn't know about. I say newest because we haven't known about it till recently, but it is also probably in some ways the oldest because it has all this leftover debris from the formation of the solar system that hasn't changed over the years.
We didn't even know that a Kuiper Belt existed until the 1990s. We knew about Pluto, but we didn't know about all of the other objects that were out there.
New Horizons researcher Alex Parker plotted the positions and relative sizes of all confirmed Kuiper Belt objects from the early 1990s through the present.
Well, you can think of the Kuiper Belt as the leftover debris from the formation of the solar system, as all the gas and dust from that original cloud collapsed and made the sun and the planets. There was a lot of leftover stuff that didn't go into the sun and planets, and those leftover bits are like asteroids and comets and Kuiper Belt objects.
It's more scattered, it's more fragmented, it's spread out over a larger volume. But we now know that there are thousands, maybe 3,000 or so, maybe many more than that, hundreds of thousands maybe, of objects out there, little icy objects that are orbiting the sun.
Now, if these leftover bits are kept far enough from the sun, they don't change much. The sun's heat isn't strong enough to really make their chemistry change like they have, for instance, to the asteroids or the planets. So you can think of these Kuiper Belt objects as the leftover debris from the formation of the solar system kept in cold storage, so we can go back and look at these objects and give us an idea of what things were like during that early formation period of the solar system 4.5 billion years ago.
While observing Pluto close up was one key reason New Horizons was approved, exploring the then newly discovered Kuiper Belt was also critical. Now, in the years after the 2015 Pluto encounter, the spacecraft is fulfilling that part of its mission.
We're continuing beyond Pluto into the Kuiper Belt because we're really interested in the context of Pluto. But there's so many other objects out there, and we want to see what the more typical objects are like. And so we're going to be looking at one of those objects up close and looking at others from a greater distance as we go through the rest of the Kuiper Belt.
We're using the cameras and telescopes on New Horizons as an observatory, actually in the Kuiper Belt, to observe almost 30 other Kuiper Belt objects that we come close to, and we can study in ways that you can't from the ground or from the Hubble Space Telescope. You really can't study any other way.
When you're looking at Kuiper Belt objects from the Earth, you always have the sun at your back. And it doesn't matter how big your telescope is, it doesn't matter how fancy the camera is you put on it, you're always seeing it at that angle. And the only way to see shadows on the surfaces of these objects and learn from those shadows is by actually going away from the sun, looking at them not with the sun at your back, at the sun at your side.
We're also studying about 5 other very large objects, small planets in the Kuiper Belt, to better put Pluto in context. We don't go close to those, but we can observe them from different geometries than you can observe from the Earth.
So we looked at 3 different small objects then, and then a few dwarf planets, including Haumea, Makemake, Quaoar, and we took pictures of those at phase angles you can never see from the Earth.
And we can learn more about their surface properties and a little bit about their satellite systems that you can't learn from down here in close to the sun.
These distant observations, however, will be nothing like the close flyby of MU-69, Ultima Thule.
MU-69 is a cold classical object, which means it's on a very circular orbit around the sun, very low inclination. Basically, that means that nothing has happened to it. Pluto has had all sorts of things happen to it, whereas MU-69 is pretty much where it started. And nothing's happened to it, it's just been in cold storage the entire time.
It's in an orbit that is a very stable orbit that looks like it has been undisturbed since the very beginning of the solar system. And therefore, it's one of the things that planets were made of, and that you just didn't get to make a planet out there because objects are so sparsely scattered there, they just didn't come together to make anything larger.
The interesting thing about 2014 MU-69 is it's actually quite common. That we believe that there are many objects out there just like it that are 20 to 40 kilometers across, sitting in the cold classical belt. And by visiting MU-69, we're going to see what the Kuiper Belt is generally like after we've explored its most colorful and unique resident.
If you go to something like Pluto, which is larger and more geologically active, you're looking at something that grew like a planet grew. It grew up out of pieces and dust and debris that coalesced and formed through this process of accretion. But that process is somewhat violent, and it heats the object and it processes it from the original state of that material. MU-69 could well be one of these primordial chunks that initially collapsed out of the solar nebula, and was the processing that it underwent during that collapse event should be very minimal. So this really gives us a glimpse into what those first stage planetesimals really looked like.
So it's in some ways more primordial than Pluto, and can tell us a lot more about what the solar system was like 4.5 billion years ago.
And that's why MU-69 is so important, because it's a very primitive object. It hasn't interacted much with the large bodies in our solar system. And so that's why it's going to be so exciting on January 1st, 2019, to see the new pictures of MU-69 close up.
In many ways, the MU-69 flyby is even more challenging than the Pluto encounter, which is why planning the approach to Ultima has been so intense. That's next. In the closing months of 2018, New Horizons sped closer and closer to Ultima Thule, 4 billion miles from Earth, and 13 years after launch. Its long-range camera returned multiple images of Ultima against the dense star fields of the center of the Milky Way. Custom software developed by the science team canceled out the stars, leaving only Ultima ahead. But there were miles to go and myriad decisions before the New Year's Day flyby. On most of planet Earth, it's Thursday, September 6, 2018. But for the men and women of New Horizons, it's already January 1st, 2019. The science team has gathered at the Applied Physics Lab for what they called the New York Times ORT, one of a series of operational readiness tests to practice all aspects of the upcoming flyby. This one focuses on how to analyze the data that will be returned by the spacecraft on New Year's Day and immediately afterwards.
All right, well, it's good to see everybody here, like deja vu all over again. We have spent 3+ years planning for this flyby, and we are on Ultima's doorstep.
They need to practice now, since the flyby itself will happen almost instantaneously. Until almost the final day, Ultima will be just a few pixels across.
For Ultima Thule, it's more of a classical flyby where the object will show up being resolved only days in advance, only to a few pixels. And it's really only the day around the flyby where you really get to see what the object looks like.
There's a lot that's going to be happening right around the encounter, and we only have one chance to do it right. So we practice like it's the real thing now, so that we get it right in the future.
It's nicknamed the New York Times ORT, since the hope is that the images and science will be significant enough to be featured on the front page of one of America's leading newspapers, just as happened after the Pluto encounter.
With this operational readiness test, it's exercising all parts of the process. It's exercising the tools that the scientists use, the meeting schedules that we have set up, the communication paths that we have, and the product generation for press releases and press conferences.
Of course, since the Ultima flyby is still not quite 4 months away, and MU-69 is still just a tiny dot, the data they'll be analyzing in September is simulated, developed by John Spencer, Kathy Olkin, and others, using solar system objects that might resemble Ultima. Just as will happen at Flyby, the different science theme groups adjourn to their separate rooms to access and analyze the data. The GGI team, Geology and Geophysics Investigation, is the largest. Confronted with images of what MU-69 might look like, they start trying to understand the basics of the new world, or worlds, just encountered.
We don't really know what is out there. We're flying into the unknown. We have never seen an object like this. It is the coldest and oldest and most distant object that any spacecraft has ever flown past. And as a result, we really don't know what to expect.
The simulated images resemble what the 2017 occultation results seem to show. An object that's either a close or contact binary, with a possible small moon. In this exercise, they start calling them objects A, B, and C. While having multiple objects might make Ultima more scientifically interesting, it would complicate navigation and targeting.
What is the nature of the target? Is it a single body? Is it a multi-body? There's been a lot of debate about that, but if it turns out to be a multi-body, like a split target or a target with a large moon, it could complicate the understanding of the motion of the primary body, the one that we really want to take the most science from.
If MU-69 turns out to be a binary, like Pluto and Charon, both objects might be spinning about a point that's off-center.
If we had that kind of situation, we would have to make some judgment calls in the final days about which object to point at and so on and so forth.
One goal of the ORT is to have the various teams interact. Veronica Bray from the Geology Group brings her hypothesis about the images to the Atmospheres Group.
I had a kooky question for Atmospheres. Sure. This is pinker, and so there might be a difference. So I guess keep an eye out if you, and let us know if you see anything.
Members of each team focus intently on different aspects of the data, concentrating on deep analysis using their individual expertise. Some are skilled in developing software to help analyze the data. Others specialize in geological interpretation. PI Alan Stern moves from room to room, nudging the discussions along, carefully watching the process. Deep technical and scientific debates erupt, and soon the fact that the data is simulated seems forgotten.
So ORTs are these weird environments where it's all fake data made up, and it's not a perfect representation of the universe, or MU-69 in this particular case. It's kind of close, but we're creatures of habit. So when we get this data, we sort of fall into treating it like it's the real thing, and after a couple of minutes, we lose sight of the fact that, you know, somebody might be trying to trick us. No, we're taking this, we're trusting this stuff that's in front of us and taking it as far as it's going to go.
They're taking this data seriously because, unlike a mission where you go into orbit or you have a rover that's going to be there for a year, 2 years, 3 years to gather your data, we're a special forces team. We have minutes, we have seconds to gather this data.
Everybody wants to get all the information, even out of the simulated data, because they want to make sure that they can do it right when it comes time for the actual encounter.
Think of it, after 13 years of travel through space, it's one moment. That's why they take this so seriously.
Every aspect of what will be happening at the flyby is being exercised. Representatives of each science team gather with public affairs specialists to brainstorm what discoveries to feature in press releases and press conferences.
We are now on the evening of January 1st, and we got our first data, and the science team worked with it for a few hours, and now it's 10 at night, and we're deciding what to have in the press conference and the release for tomorrow.
We will be able to say that it worked.
Yes, the next morning.
The next morning, an image goes out, and then we have a new image comes in.
We run tests, kind of a day in the life, a week in the life. What's going to happen during the planning activities, during the maneuvers, the trajectory correction maneuvers, just to make sure we know who's going to be where, when, what data we're expecting, and what happens if something doesn't come down exactly as we'd anticipate.
Just as will happen after the MU-69 flyby, Day 2 brings new data to add to the understanding of Ultima Thule. As with the actual flyby, some initial ideas are jettisoned, and new ones are proposed and tested. Once again, the individual teams carefully digest the new information, discuss what hypotheses seem best, and share their evolving conclusions. As with all the various ORTs, a key outcome is a series of lessons learned. For this one, they range from simple, making sure the sources and sinks of plentiful coffee are known by all, to reducing the number of meetings to allow more time to analyze the data.
The operational readiness testing that we're doing really makes or breaks the flyby. Unless you luck out and everything just goes according to plan, you have to be resilient to surprises and the unexpected. And the team has to be able to respond to those effectively and decisively. So if you don't do operational readiness testing, then you'll end up with a very brittle team that cannot respond effectively to the unexpected.
But the real value here is We practice interacting and working with each other just a little bit more as a team, and communicating and how to reach a consensus and discuss things and know who's good at what. It also teaches us more about what's coming and what are the types of data that we're going to get and the kinds of things that we really need to be ready to process and analyze when the real data comes in.
Day 3. Did the New York Times ORT succeed in capturing the front page of the New York Times? As the 3 days of intense analysis of the simulated data comes close to the end, John Spencer revealed what the actual data looks like, so attendees can assess how well they did.
Okay, so I'm going to make a few concluding remarks at the end of this ORT. And let me start with this. 3 months and 3 weeks from today, we will be assembling en masse in this room, in this building, to begin the actual close flyby operations on the 28th of December. It will not be very far in the future. And we're the one and only. There's no other mission like it. You'll probably look back on it the rest of your career as one of, if not the highlight, certainly one of the highlights of what you were able to accomplish for science and for exploration. I think we're ready for this. We have some work ahead. The navigation task has already begun. The hazard work will begin in late November. For where we should be here at the end of this weekend in September, this was a complete success, and I couldn't expect us to be any more ready than we are.
Hey.
After the ORT, 2 main tasks remained and got steadily more intense: the hazards campaign and fine-tuning the approach trajectory. Mark Showalter, who's heading the hazards team, works at the SETI Institute, which coordinated the public naming contest that came up with MU-69's informal nickname, Ultima Thule.
Thule was this place that is far to the north, the most northernmost, coldest, most distant place.
Although mythical, the island of Thule even appears on some medieval maps.
Ultima Thule means beyond Thule, which means beyond the limits of the known world. And we're definitely going to a place that is beyond the limits of the known world.
As to what Ultima will look like, even the world's best experts have no clue.
It's going to be colors, it's going to be craters, it's going to be weirdly shaped, it's going to be a different kind of object than anything we've ever seen before. It is totally unexplored territory.
It's also much smaller, so it's harder to see and harder to know exactly what it might look like, what it might be shaped like, or whether there are multiple objects, whether it's got satellites orbiting it or not.
As New Horizons traveled onward through the Kuiper Belt, making distant observations of many cold classical objects, it verified that some 30% of them are binary objects. And we now know that another dwarf planet, Haumea, and a Centaur asteroid, Chariklo, an escaped Kuiper Belt object, have rings. What does that mean for potential debris around Ultima?
We have a hazard team of about a dozen scientists who are working in all aspects of this problem, and we're effectively in the crow's nest of New Horizons. It actually kind of feels that way. We're out there, we've got our telescopes looking ahead for any sign of rocky shoals, anything that might be dangerous to us. This object, Ultima Thule, might be at the center of 1 or 10 or 100 small moons or a cloud of dust. These are the things that we simply don't know, and we have to know before we get there, because we're moving along through the solar system at 14 kilometers a second. That's about 10 miles per second. And anything even the size of a tiny BB, much smaller than a pea, could essentially damage our spacecraft to the point that it can never send down the data.
Before the Pluto flyby, the mission had sent spacecraft components to the White Sands Missile Test Range, where they'd been subjected to what were called gun tests, which showed potential damage.
So we could lose everything if we don't have a safe flyby of Ultima Thule.
The hazards team will continue analysis through mid-December, using the latest images from the spacecraft.
We'll get closer and closer, it will get brighter and brighter, and anything near it will also slowly begin to appear.
Those same approach images will also be used for any final trajectory correction maneuvers to improve the science or safety of the flyby. The TCM of December 2nd saw New Horizons fire its thrusters for 105 seconds, adjusting its velocity by about 2.2 miles per hour. That's a fine-tuning of just over 1/15,000th of its 34,000 miles per hour.
Autonomy is reporting nominal status. Thank you.
But even with the success of the Pluto encounter, this flyby is above and beyond any previous mission.
For Pluto, we thought we were really pushing the limit, and we were. This is even more challenging with Ultima Thule because it's another billion miles further out, it's considerably smaller, it's a very, very faint object.
It's a little trickier getting to MU-69 than it was to Pluto. With MU-69, we observed it with Hubble Space Telescope, but we couldn't tell exactly its orbit in the sky, so we had to monitor it over time and make occultation observations of it.
New Horizons is also 4 years older, and its plutonium fuel is supplying less power.
So it's been extremely challenging, first just to get observations of it, but we had to combine something on the order of 48 images that are 30-second exposures each to pull this object out of a star field.
And since Ultima is 4 billion miles from Earth, signals to and from the spacecraft take more than 12 hours there and back, even traveling at light speed.
It's a combination of the object being fainter, further. We have longer round-trip light time, so the reaction time takes longer with a 12-hour round-trip light time.
With what little information that they have, they realize they're going to really have to focus in on it and pull this information out. It's time sensitive. So consequently, they're doing the push-ups, the sit-ups, the laps around the pool, getting ready for what's really coming.
The details of what has to happen when are mind-blowingly complex.
Choreographing the ground operations to be done in time, to get the images downlinked at the lower data rates because of the longer distances, do the ground processing, get the information up in time. It's a lot more challenging for Ultima Thule than for Pluto. And Pluto was pretty challenging. So we're shattering all the records really in terms of like every maneuver we do from here on out is the furthest maneuver ever done from Earth for any mission, so that we basically thread the needle as it said, and we hit the target, the aim point as we fly by MU-69.
It's an Olympics competition for brain power, for something that could go wrong, something that will go right, unexpected discoveries. It's thrilling.
I'm looking forward to some pleasant surprises and getting to see some science return, see what this target really looks like.
It's been years and years and years people have dedicated their lives to this mission, and now here it comes. And it's going to come upon us faster than we ever imagined. And I think the expectations are high, the energy is high.
As Ultima Thule starts to reveal itself, we'll start to answer these questions, you know. Is it a binary? Does it have a moon?
We can't wait to start this game.
If all goes well, New Horizons will fly by Ultima Thule on January 1st, 2019. What kind of brand new world will we discover this New Year's Day? Will last-minute hazards emerge? Stay tuned.
People sometimes talk about the golden age of space exploration, and they might mean the moon landing, they might mean Viking or Voyager. What they may not realize is we're in a golden age now. We have rovers on Mars. We have missions that are discovering planets around other stars.
We have upcoming missions. The Lucy mission that's going to take us to Trojan asteroids that we've never visited before. The Psyche mission, which is going to go to a metallic asteroid, something we've never seen up close.
There's amazing discovery going on right now.
Pluto was one of the last places in our solar system to be explored. And so I think it is making people wonder what's next. You know, what's the next big discovery that we're going to make? Where's the next big place we're going to go to?
For New Horizons, the next, of course, is Ultima Thule. But the spacecraft may still have decades of productive exploration ahead.
Our official extended mission only runs through the spring of 2021, about 2.5 years after the flyby. Now, despite that, the spacecraft has plenty of power and fuel, and it's in very good health. All the instruments are working, and so are all the spacecraft systems. And we could, we believe, operate New Horizons another 20 years, maybe longer, just like the Voyagers, going on exploring. I tell people as I expect the spacecraft to still be operating in the 2030s, I'm just not sure if I'll be operating in the 2030s.
I've had many lucky things happen to me in space exploration, but I think the most satisfying thing is to go to a new object that we knew nothing about, Pluto, and see it and explore it and show what we saw to the public in such a dramatic way.
Kids these days, they grew up with all the major planets except Pluto already explored. It was a done deal. This was their first chance for a new exploration of what was one of the classic planets, an entire world.
With almost 2 billion mentions across the web and social media in July 2015, the Pluto flyby was NASA's most popular event to date. But as mission members shared the scientific results and engineering successes through interviews and public outreach, they began to realize the human impact of New Horizons extended beyond astronomical discoveries.
We have inspired a whole generation of young scientists to go and explore and to think about space, and most important, to do their math homework.
The most powerful story that I can tell is after giving a speech in Florida about 9 months after the flyby. There was a line, and a woman was in it who came to me crying. She was literally crying. And she said, I wanted to shake your hand because my son was flunking out of high school until the New Horizons flyby. And he watched it, and he said to me on flyby day, I want to grow up and do that.
You have to see the look on the faces of the kids when you show them these pictures and you talk about Pluto and all the excitement of being involved in seeing this stuff.
And she said, it's his second semester since the flyby, and Mr. F student has become an A student. And I want you to tell the people that work on New Horizons that you turned him around. And wow, as a scientist, to have that kind of an impact on somebody's life, for those of us who worked on this project, to hear personal stories like that, nothing could be better. The fact that we can move people that way with one little robot 3 billion miles away.
From the first push for the mission in 1989 up through the 2019 flyby, it's been a long ascent with hard work and many challenges met and mastered. The summits of the solar system have been achieved, a feat of passion and persistence that will live for the ages.
We've learned so much more already just by having seen Pluto. And that's going to be the gift to the next millennia, is opening up that perspective that was closed to us before going out to see Pluto.
When we talk about the golden age, we're always thinking about the past. We don't think about actually being in a golden age till you are in the future and looking back and realizing all the amazing things that you did, and maybe were so busy you didn't realize it, or it was just commonplace.
Have we come to the end of exploration of the solar system? No way! There's way more things to explore out there that we've not seen.
Think about this. The New Horizons team explored farther than any humans in history. And the only humans who are going to break that record in the foreseeable future are ourselves with our next flyby in 2019. It's mind-boggling to think that our friends and colleagues did something of that scope. And it's very special to have been a part of that.
10, 20, 30 years from now, just like when we were looking back at the moon landing, people are going to be looking back at now and saying what an amazing time that was. And my hope is that 30 years from now, when they're looking back at this time, they're going to be doing even more amazing stuff.